Hi everyone. Okay, we did most of this in class. So we talked about just some common logarithms that we should know the answer to, and then when it's undefined, because the argument has to be greater than 0 in order for it to be defined. Here are the steps to solving. What are we solving today? Today we're only solving exponential, and then on the next one we'll solve the logarithmic equations. That will be 6.4. Okay. We did example 1 A and B in class, and one answer we were able to find in our head, and this answer we had to use a calculator. And this video just picks up on example 2. Okay, so thanks for being with me. Are you ready? I think this is just what makes this one different? Let's talk about that. What makes these two examples different than these two? It has to do with the base. What base was here? 2 and base 2. So we had to use log base 2 to solve, but what base is here? E. So what will undo the E? What's the inverse of E? E to the ln is 1. So the ln, or the natural log, will undo the E. Who's ready? I'm ready. Okay. Should I do it wrong to start? Should I do it wrong? So here's the wrong way. The wrong way to be to take the ln first. Why is that wrong? Is the ln touching the E? No, the 3's in the way. So you can't go hi-ya karate chop. I don't think that eraser works. Let's try and find an eraser that works. Okay, so in order to take the logarithm of both sides, the base has to be by itself. Now it just looks like that 3 is hanging out, but you have to get rid of the 3. Okay, so you think, how do I undo this 3? Am I going to add, subtract, multiply, divide? Now the 3 is attached by multiplication. So the way to get rid of the 3 is to divide both sides by 3. So that's step 1. Isolate your base. Our base is E. How come 12 wasn't the base? It doesn't have an exponent. Okay, so E is our base. Step 1. Isolate the base. Step 2. What does it say? Take the log. Or the natural log. Since our base is E, we're going to take the natural log of both sides. So I'm going to say ln here, and then there's never any room unless you knew it was coming. You're like, how do I take the ln? You just try your best, okay? So when you take the natural log of an E, do you see how they're touching now? Then you go, what do you say? You go hi-ya karate chop, and the exponent, all of it, 2x plus 1 is now on the ground with this, the ln of 4. So there's no more exponents. Ow. I just hit myself. Okay, if you want to think about it like a princess up in the tower, so this princess is up in the tower and you need to bring the princess down from the tower in order to solve for x, and the only way to bring the exponent down is to take the log of both sides. Okay, now how do we solve for x? Well, you get rid of the 1 and the 2. So we're going to subtract 1. Can you do, will this be the log of 3? No, no, never, never. The ln of 4 is its own number, and I don't know what it is. It's hiding in the calculator because I don't know e to what base is 4, so that's in the calculator. Final step is to divide by 2. Okay, the exact answer. This is the exact answer is here. How would I get the approximate answer? To get the approximate answer, you plug it into the calculator. If I have I wonder if I'll have time to show you all this. Okay, watch. ln of 4. Well, first of all, can you guys all see this? Is that correct? No. So after you put ln of 4, you got to close that parenthesis and then put minus 1. Now watch. Divide by 2. Is that correct? No, not at all. Because the ln of 4 minus 1, all of it needs to be divided by 2. So watch. We're going to go to here. Have you ever done second delete to insert parentheses? And then I'm going to insert parentheses there. Do you see how now it says ln of 4 minus 1, all divided by 2? So practice doing that. Let's see, do I get this right? Let's see. 0.193. Okay? What if you wanted to do it in pieces? You could do this. Watch. ln of 4 equals minus 1 equals divide by 2 equals, like that. Same answer. Okay, this one is supposed to be a you try. We're going to do it quickly. Is the base by itself? No. What do we need to move? We need to move the 1. If you have that line, it's just like a typo. It's not where your answer is supposed to be. Divide by 3. Our base is e, and that's going to equal 3. Now, how do we save the princess from the tower? See how the x is up in the tower? We cannot solve for it while it's up there. We've got to bring it down. What operation brings it down? What math operation? The natural log. How come we're doing the natural log? Because what's the base? The base is what? E. So, haya karate chop. And we get x minus 1 equals the ln of 3, the natural log of 3. Final step, get x by itself. Add the 1 to both sides. The exact answer is the ln of 3 plus 1. And then the approximate answer, we need to know both. Ln of 3, like that. Make sure you close the parenthesis. If you close the parenthesis, you'll get it right. Plus 1. How'd I do? Did I get it right? I'm going to check my answers. You can round that 8 or leave it. I like to round. Did I get it right? I did. Fantastic. Let's keep going. New instructions here because we don't just have one base. Do you see how we have 2 bases? A base equals a base. If an exponential equation has exponential expressions on both sides, then here's what we're going to do. Try to rewrite the bases with the same base and solve as we have done before. We did this in the last chapter. So right here, this 2 is to the power of 3x plus 4, but can we rewrite the 8 to have a base 2? But it still has to be equals, right? So can these guys have the same base? 8 to what power? No, that was wrong. I said that wrong. 2 to what power is 8? 2 squared is 4. 2 to the third power, 2 times 2 times 2. 2 to the third power is 8. Do we have the same base? What do you know? What do you know? What are we going to do with this 3? Distribute? Okay, watch. 2 to the 3x minus 3 equals 2 to the 3x plus 4. See how I distributed that? So about a month ago, you're like, that was so hard, but now it's seeing it again, you're like, oh yeah, I remember that. Okay, do we have the same base? Yes. So when we take the log of both sides, then the bases cancel, and we have 3x minus 3 equals 3x plus 4, like that. Oh, this is good, you guys, because this is going to be all over our test. Okay, do you see how we have 3x and 3x? This is good. This is all over benchmark exams and SBACs, haya, and then this is where kids, you just stop writing it down. But that's wrong. No. Keep going. What does the next line of math say? Negative 3 equals 4. Okay, in your head, does negative 3 equal 4? No, that is a false statement. False. Liars. So your answer is no real solution. Have you ever seen no solution on a benchmark? Yes, in those tables where you check it, you check mark. 1 solution, 2 solutions, or no solutions. Okay, so there you go. Okay, why does this have a star? I don't know, it's a mystery. Can you write 2 and 5 to the same base, like we did here, the 2 and the 8? No, so what the heck? How do you solve that? Okay, so when your bases don't match at all, here's what we're going to do. Asterisks. Ready? We will take the natural log of both sides. What the heck? I know. I wonder what's going to happen. Sure you're wondering. So we're going to take, you ready? ln of 2 to the x plus 2 equals the ln of 5 to the x minus 3, or the natural log. Okay? Drum roll, please. Remember we did those properties, and those properties say anytime you have the log of this exponent, where is this exponent allowed to go? Down in front. And where is this exponent allowed to go? Down in front. How come we didn't do that on the front? We did. We moved this x minus 1 down in front, and then the ln of e equals 1. Okay, so we moved it down in front, but then it was just times 1. So we did do it here, you just didn't really realize it. I love these problems, these questions. Here we go. Do you like my colors today? Kind of like boy and girl, running out of my fancy pens. Okay, don't worry, we're still here. We have to solve for that x, yeah? Okay, what should we do next? Good thing you have a teacher. So we brought it down in front using that power, it was a power property of logs. Now we're going to distribute. What'd she say? Distribute. How are we doing on time? We're good. Distribute. Ready? Get set. X times the ln of 2 plus, remember that plus sign here? Plus 2 times the ln of 2. Where are we going with this? Don't worry, I got you. Equals x times the ln of 5. Is anyone offended when I say ln minus 3 times the natural log of 5? Ah, that's my phone. Hold on a second. I did not answer, if you're wondering, and we're back. Let's finish this. Where is our x? Do you see our x? We have 2 of them. Why do we have 2? Here we go. There's 2 of them. So we need to get the x's onto one side and the numbers onto the other. Are you with me? This is a number, so I'm going to move this over here. 2 times the ln of 2. And I'm going to leave these numbers over here. And I'm going to move this x to the left side. What is she doing? Don't worry. We'll get it all cleaned up. Now, this is not a division. The lines is a little weird. We're subtracting. X times the ln of 2 minus x times the ln of 5 equals negative 3 ln of 5 minus 2 ln of 2. You should feel the weight of this problem. This is actually a preview into a calculus problem called implicit differentiation. What? Okay, I'm talking calculus while trying to do algebra 2, which is now called math 3. Okay, what did I just do here? Think about it. What did I do from here to here? This line didn't change. What did I do here? Did I factor out the x? Yes, factor out the x. Okay, next step. How do you get x by itself? We're going to divide by this. And did I give myself enough room? No. Okay, what happens when I do that? Cancels. You ready? X is equal to this wonderful, beautiful math. Isn't that beautiful? You can't combine these. Like ln of 2 minus ln of 5 is not ln of negative 3. Okay? Practice finding this in the calculator. You should get 6.782. Okay, this was a big thing. We took the ln of both sides, and then the key was to move the x's to the left and move the numbers to the right, factor out the x, and then divide by this difference. And this is the final answer here. If none of the above can be done, try factoring or using a graphing calculator. So this is pretty cool how we factored this. I'm running out of time, but do you see how this is just like saying x squared minus 4x minus 5, except they're e's? Okay, pause the video and copy this down for your last example. Factor, ZPP, solve for e. The final step in solving for e is to take the ln of both sides. ln. All right, thanks for watching. This is the only solution because this is not in the domain. You can't take the ln of a negative.